Okay, the only way to get a triangle with, let's start with the 30 and the 60. The only way to get a triangle with all sides 60 degrees is if we have an equilateral triangle. So we have that side and that side and that side equal. So this is an equilateral triangle. That means this is 60, 60, and 60. I only chose this because I want something that is equal. I'm sure that this angle will be 60 because it's an equilateral triangle. That means all angles are equal. And the second thing I would need to know is that all sides, because all sides are the same, so I would say this will be, let's just say this is 2, 2, and 2. So if we have the hypotenuse and we have the base, we need the height. So if we were to do like that, so this will be 90 degrees and this will be 90 degrees. What would this be? This would be 30 degrees and this would be 30 degrees because we're dividing it by half. We're trying to divide this triangle in half. So that's it. We have an equilateral triangle, sides are equal, angles are equal. Now we have our 30 degrees and our 60 degrees. We need to find the height. How would we find the height? So if you have, this is where Pythagoras comes in. So I guess you guys know if we have a triangle like this, and this is A, and this is B, and this is C. So to find, if we have something like this, and to find A, because that's what we're trying to find, the height, this is A. We know the formula for Pythagoras is C squared equals to A squared plus B squared. We have plus B here that we need to deal with because we just want A squared. So if we were to look at it like a balance, this is the balance and this is the balance because this is the equal sign. If we were to remove B squared from here, we have to remove it from this side as well. Otherwise, it won't balance. So if we do minus B squared, we need to do minus B squared on this side. So basically, A squared, this one, is C squared minus B squared. We're happy with that? And A, so we want A on its own. We don't want A squared. So A would be square root, the whole thing, C squared minus B squared. Okay, so now we have that. We know our A is what we need. We know our our C squared, the hypotenuse, is 2 squared minus, and we know our base. Our base, it's like this. This is 1 and this is 1 because the triangle has been divided. We need a right angle triangle to find Pythagoras. Pythagoras only works in right angled triangles. So this is our triangle basically, this. And so our base would be 1 in this case, even though the whole part is 2, here until here, it's 1. So it's 1 squared, square root the whole thing, will be 4 minus 1, 3, square root of 3. So our height is square root of 3. Now that we have all that, we need, so we have our this and this. Now we need SOHCAHTOA. Let's try and find, what are we trying to find first? Let's try and do the sines. So we have sine of 30 and sine of 60. And we know from SOHCAHTOA, sine is opposite of a hypotenuse. So what triangle should we choose? Let's choose this triangle. 1 second. we'll use this triangle. So sine of 30 is opposite of our hypotenuse, which is, so if we say this is sine, opposite is 1, hypotenuse is 2, so that's a half. Sine 60 is opposite again of our hypotenuse. Opposite, so this is 60, opposite is square root of 3, hypotenuse is 2, so it's square root of 3 over 2. We can do the same for cosine, so cos of 30 and cos of 60. Cos is adjacent over hypotenuse, adjacent over hypotenuse, adjacent over hypotenuse. So if we look at cos of 30, adjacent is square root of 3, hypotenuse is 2, so that's square root of 3 over 2. Cos of 60, adjacent is 1, and hypotenuse is 2, so that's a half. Have you noticed something? The sine of 30, which is a half, is the same as the cos of 60, which is a half. And the sine of 60 is square root of 3 of 2. It's the same as the cos of 30 is square root of 3 over 2. In the exam, I won't do all this. I only did this to show you guys. If I was in the exam, I would just know, I know this triangle. So I'd be like, okay, I need a triangle. That's 60, 60, 60. So that would give me 30, 60, and 60. I know if I do 2, 2, 2, this will be 1, 1. And this will be square root of 3. So now I know if I want cos of 30, it'll just be adjacent. So adjacent, which is square root of 3 over hypotenuse. That's it. That's how I would do. But however, we only found this and this. And actually, we forgot about tangents. So if we were to do tan of 30 and tan of 60, so again, opposite over adjacent. So opposite, square root of 3 over adjacent, 1, which is square root of 3. Have you understood it? Okay, so what I wanted to do as well is show you this one now, 45. Again, we need a triangle. Would use is, let's do this. So if we have a 90-degree angle, triangle, a right angle triangle, and we want these to be 45 degrees, then it'd mean that this is the same as this. It's an isosceles triangle. Can you guys see how many things we've done so far? We've talked about isosceles triangles, we've talked about equilateral triangles. I think I should add it here. Isosceles triangle, equilateral triangle, okay, so if we know, let's just say 1 and 1. There's a reason for these ones, you know, but I don't want it to go long, but I'll just show you. So if we have a isosceles triangle and this is 90, we know angles in a triangle add up to 180. So 180 minus 90 gives you 90 divided by 2 gives you 45. So this will be 45 and 45. I'm sure of it. You can't just assume, you can't just draw a triangle and say this will be 45, this will be 60, this, no. But I know this, if this is this isosceles triangle, I'm sure this will be 45 and this will be 45. This is 1 and 1. Again, we're going, if we use Pythagoras somewhere here, so if we want the hypotenuse, CC, it's going to be a squared plus b squared and then square root. So it'll be, if we wanted this, it'll be 1 squared. So to get the hypotenuse, it's 1 squared plus 1 squared and then square root, which is square root of 2. So we've added here square root of 2. If we do the same now, if we do, let's do it here, down here. So if we do sine of 45, cos of 45, and tan of 45, we know sine of is opposite of our hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So sine of 45 we know will be opposite over hypotenuse. So opposite over hypotenuse, that's 1 over square root of 2. Cosine of 45, again, it will be, let's say, adjacent 1 over hypotenuse. So 1 over square root of 2. And then tan of 45. Tan of 45 is opposite over adjacent. So that's opposite over adjacent. So that would be 1 as well. So yeah, I hope it helps. So you needed to know the triangle that makes, I don't know what that makes, that has angles. And then you have the SOHCAHTOA and the Pythagoras. Pythagoras only works in right angle triangles. So that's why we have the right angle triangle. Isosceles triangle, it means that, well, actually this one, it means that 2 sides are equal. An equilateral triangle, which means all sides are equal. I hope you've had as much fun as I did. I hope you've remembered something.